Good morning, class. Good morning, everyone. Good morning. How are you all doing? Hello. Hello, hello, and hello. Good morning, class. Good morning, Mitch. Good morning. So I believe last time we have done certain questions, है ना? Good morning from Tamil Nadu. Good morning, Tamil Nadu. Good morning, Tamil Nadu. Okay, so we were doing certain questions, and I believe I should be doing certain more questions. Good morning, everyone. Good morning, Bacho. Good morning. Welcome to the class. And today's session is very, very important as far as the atomic structure is concerned. I mean, on the basis of today's lecture, many numericals you will be able to solve if you get it correct. So shall we begin without any delay? Come on, let's begin that. Come on. So we were doing certain things last time. So we'll begin with this stuff. Come on, boys and girls, stuff over here. See, if there is a transition of electron, this is orbit number n1, orbit number n2, and orbit number n3. If electron falls from n2 to n1, है ना? n2 to n1, a photon will be emitted, है ना? And I'm assuming the wavelength of this photon is say lambda 1. And if it falls from n3 to n2, again a photon will be emitted of say lambda 2. And if electron falls from orbit number n3 to n1, again a photon will be emitted and its wavelength will be say lambda 3. Can you find out the relationship between lambda 1, lambda 2 and lambda 3? How many believe that will be lambda 3 equals to lambda 1 plus lambda 2? How many believe that answer will be lambda 1 plus lambda 2 will be equal to lambda 3? Come on, how many of you? Come on, be quick. Show me a thumbs up. Okay, okay. Manish says so. Rutika says so. Okay, okay. Evangeline says so. Kavita says that. Saiti, good. Okay. Zoology class, Ninna Undapna. But एक तो तेलुगु नहीं आती है. तुम मुझे तेलुगु में सवाल पूछ रहे हो. But I believe that this is not a zoology class. Okay. No, it's a wrong answer. It's a wrong answer. See, there is no law of conservation of wavelength. There is no law of conservation of wavelength, but there is definitely a law of conservation of energy. So I believe that this energy gap will be suppose say delta E1, this will be delta E2, and this energy gap is definitely delta E3. And I know that delta E3 will be equal to delta E1 plus delta E2. Yes or no? Everyone will agree. And since we're talking about the photons, and the relationship is that Hc upon lambda 3 is equal to Hc upon lambda 1 plus Hc upon lambda 2. Will you all agree? Hc will cancel, and if this cancels, I believe this will be 1 upon lambda 3 equals to 1 upon lambda 1 plus 1 upon lambda 2. If I can take an LCM, 1 upon lambda 3 will be lambda 1 plus lambda 2 upon lambda 1 lambda 2, and lambda 3 will be lambda 1 lambda 2 upon lambda 1 plus lambda 2. Yes or no? Can we say that? Can we say that? Everyone got it? Good one. Okay, good. Very good. So be careful, be watchful. Good morning, Bacho. Good morning. Okay, see that now. Acha. Okay, if I want that the photons which are emitted are having a frequency like say nu1, nu2 and nu3. Now the relationship between nu1, nu2 and nu3 will be how much? Come on. Again, delta E3 will be equal to delta E1 plus delta E2. Will it be mu3 will be equal to nu1 and nu2? Summation of that? This is H nu3 equal to H nu1 and H nu2. H will cancel up, and I believe nu3 will be equal to nu1 plus nu2. So this relationship, what you were telling, is correct for frequency but not for wavelength. Be careful, and these are like repeatedly asked questions. Okay, good, very good. I hope that is done. So can we move ahead? Okay, this is a very extremely important session, bacho. Very important session. Can I go? Okay. So, okay, now there is one more thing which we have to understand. These are important questions, है ना? See that stuff. Say we already know that 1 upon lambda is equal to r z square 1 upon n1 square minus 1 upon n2 square. Now, whenever a photon is emitted, its wavelength can be given definitely by this kind of arrangement. Yes or no? Okay, good, very good. Now, suppose that we are having the same transition, say for example, to orbit number 1 to orbit number 2 or 2 to 1 in two different species, maybe hydrogen, maybe helium, है ना? So I believe if for hydrogen I'm going with that, this n1 will be beta 1 square and this will be 2 square. But again for lambda of helium plus, if the same transition 2 to 1 occurs in helium plus, it will be r z square 1 upon 1 square minus 1 upon 2 square. And if I take a ratio, will you all agree that this will cancel? Because it's same 1 upon 1 square minus 1 upon 2 square. And this will also be same. And R also will cancel. So can I say that when this thing is same, R will be gone, this will be gone, and 1 upon lambda will be proportional to Z square. Yes or no? Can I say that? For the same line, can I say that? And that also means that lambda is proportional to 1 upon Z square. 1 upon Z square. This is very important. I'm going to give a question which is extremely important, and chances of that question coming in your exam is also very high. Okay? Having done that stuff, what I'm saying, please write down a question. If wavelength of the photon emitted, in first Lyman series, if the wavelength of the photon emitted in the first Lyman series of a hydrogen atom, first Lyman series means 2 to 1 in hydrogen atom, is lambda is given as 1210 angstrom. If the wavelength of first line of Lyman series in hydrogen atom is 1210 angstrom, find the lambda of the photon emitted in in sodium 10 plus, in the first Lyman series of sodium 10 plus. When the electron is going from 2 to 1 and 2 to 1, first in hydrogen, then in sodium 10 plus, Over here, the lambda of the photon is 1210. What will be lambda of photon in sodium 10 plus? Come on, solve it, be quick. And I know one thing in the previous discussion, that lambda of sodium 10 plus upon lambda of hydrogen will be Z of hydrogen square upon Z of sodium 10 plus square. What is Z of sodium? Very good. Joshna, very good. Shrinu, very good. Anwar, again, very good. Keep it up. Lachana, very good. Hasini, very good. Wow. Snehlata, very good. Everyone good. Evangel, good. Preeti, good. Manish, good. Very good. Brilliant. Kusuma, good. This is that, na? So Z of sodium is how much? 11. Z of sodium is 11. And I believe now this will be lambda of sodium 10 plus. This is given as 1210 is equal to 1 upon 11 whole square. If we solve it further, I believe lambda of sodium 10 plus will be equal to 1210 upon 121. This will be 10 angstrom. Very good. Extremely good. So can we go for the next question? Is that clear? Remember that whenever we are having same transition, I mean, like maybe say 4 to 2, maybe to 5 to 3, whatever it is, like say, if the transition is same in both the atoms, I mean, this part will cancel out, R will cancel out, that lambda will be proportional to 1 upon Z square. Remember that. So your job is to remember certain tricks, how to handle those questions to make it as fast as possible. We're going to, I believe that you will get the material, and moreover, You better ask this all this to management. They will handle all these queries for you, beta. Okay? Okay. I'll be taking track 1. Okay, out here on the online as well as now offline. And I believe that they will give you some material kind of thing. You can ask it to the management. है ना? इधर देखो बच्चा. Please come over here. This is important. देखो. In hydrogen atom, when electron jumps from orbit number 2 to orbit number 1, it will emit a photon. It will emit a photon of wavelength say lambda. I'm saying that in helium plus, this is N1, this is say N2. Electron should jump from which orbit to which orbit if you want photon of same lambda. Photon of same lambda. Like see, there is a method to solve it. It's a lengthy method. I'm going to share a shortcut with you. Can I share a shortcut? That if in hydrogen atom the electron jumps to 2 to 1 and in the process it emits a photon of wavelength lambda. In helium plus, which jump will give you a photon of same lambda? Very good. Srinu, very good. Joshna again, very good. See that whenever there is some say 2 to 1 in hydrogen atom, the Z of hydrogen is 1, but Z of helium plus is 2. Z of helium plus is what? 2. So this is 2 to 1 from hydrogen. Now multiply this by the Z of the given species. This will be like say multiply by 2. Answer will become 4 to 2. It's a trick, bacho. It's a short trick. The other methods are very lengthy methods, so we won't go with that. 4 to 2. Be careful. You have to multiply 4 to 2. Multiply entire thing by 2. I'll tell you one thing. Who will tell me that if it's a lithium 2 plus beta, lithium 2 plus has Z equal to 3. So this is N1, this is N2. Which two orbits will be involved in giving a photon of same wavelength? Come on. Very good. Now everyone is giving me correct answer. Snilata very good, Sindhu good, Anwar good, Joshna, Kusuma, Manish very good, brilliant. So this is say 2 to 1 for hydrogen. Now multiply this by Z. This is 3. 6 to 3. Are you getting that? Very good. Now but you understand how you can carry on to any question they give you, beta. Any question. So I am giving you, like say they carry it to 8 to 4 in helium plus. 8 to 4. Now what do you think? Which jump will occur in hydrogen? Which jump will give you same wavelength? 8 to 4 in helium plus. Which jump will come over here to give you the same wavelength? You from here to here, you multiply by Z, you coming back, you will divide by Z. Very good. So this will be like what? Divide by 2. So 4 to 2. The answer will be 4 to 2. Yes or no? Very good. Excellent, bacho. You're doing very good. Keep it up. Can I ask you some question? I mean, once you get the stuff, what will be jump in the lithium 2 plus? The jump in lithium 2 plus. Now you have got the trump card. Once you get trump card, you can come over here directly. Come on. Thank you, bache. Thank you so much. I'll try my level best. Hai na? So stay tuned. Very good. Now you got 4 to 2. What will happen to lithium? When you got hydrogen, multiply by Z now. Multiply by Z. Z is what? 3. So 3 into 4 to 2. Come on. This will be 12 to 6. 12 to 6. No, 12 to 9. No, this is 4 to 2. Multiply this by 3. 4 to 2. 12 to 6. I hope everyone is getting correct answer. All of you got it, bache? All of you got it? Can I give you one more question for the practice? Come on. One more question for the practice if you want that. Fastest fingers first. Come on. Let's play the game. So the game is that, okay, we are actually from 9 to 6 we are here. Next question. In the lithium, I am 9 to 6. What will happen over here? In hydrogen, come on, tell me first over here. Which jump will give you same wavelength? 9 to 6 in lithium 2 plus. Divide this by 3. Divide this by 3. This will be 6. Oh, sorry. 3 to 2. 3 to 2. And when you get 3 to 2, which jump will be here? Which jump will be here? In the helium. Come on. In the helium plus. Multiply by 2. Multiply by 2. 6 to 4. 6 to 4. Very good. Very good. Excellent. Excellent. I hope everyone is getting that. Everyone is getting that. Good. Very good. Superb. Superb. So can you move ahead now? Can you move ahead? एक अच्छा क्वेश्चन पूछ रहा हूं बच्चों. I'm asking you one good question. See that. In helium plus, electron jumps from 4 to 2, fourth orbit to second orbit. In helium plus, electron jumps from orbit number 4 to orbit number 2. Getting it? The emitted photon will lie in which range? First option, visible region. Second, UV region. Third, infrared region. Fourth, what do you call? Microwave region. Come on, which one? 4 to 2. 4 to 2. Come on, everyone. Focus. 4 to 2. So whenever the electron falls in orbit number 2, we belong to what? Balmer region. We belong to Balmer region or not? And Balmer is what? Visible. Yes or no? But remember that was only for hydrogen atom. This is only for hydrogen atom. This is for helium plus. But all that we have done in the last lecture, it was all for whom? Hydrogen atom. And if you look over here, the electron in helium plus going from 4 to 2. In hydrogen atom, it will be going from 2 to 1. You'll get the same wavelength. You will get the same wavelength. If it is going from 4 to 2 in helium plus, in hydrogen it will go 2 to 1, and 2 to 1 transition in hydrogen is what? Lyman series. Yes or no? And Lyman series lies where? It lies in ultraviolet region. Ha ki na bhai? This is He plus, not hydrogen. All that visible, four lines are visible. That is all for hydrogen, not for helium plus, not for lithium 2 plus. Yes or no, bhai? Everyone getting it? So be careful, bache. Be very careful. So this will lie in what? UV region, because for helium plus 4 to 2 means what? For hydrogen atom, it will be 2 to 1, and 2 to 1 we mean it is going to lie in Lyman region, and Lyman region is what? UV region, beta. Are you getting it, everyone? So are you enjoying the questions? The answer will be 1216. Anwar has got the answer also. So like say, if you want, no sir, we want to calculate that, you can calculate. You can definitely calculate. Sir, 1 upon lambda will be equal to R into Z square for helium plus 4 into what? 1 upon 2 square minus 1 upon 4 square. Put the value of R, you will get all those answers, and you will get lambda equal to what? 1216 angstrom. 1216 angstrom. And now we all know, now this is a lengthy method. We all know that as far as Vibgyor is concerned, we have got 4000 angstrom to a range of 7000 angstrom. In this region, we are into visible region. Less than that, UV region. More than that, infrared region. Yes or no? Yes or no, bhai? And definitely, this 1216 is in this region. This is lesser than 4000. So below 4000 is ultraviolet. Anything left to violet is ultraviolet. Anything right of red is infrared. Agree or not? Bolo. Be careful, है ना? Acha, if they give you a question that on a certain transition in hydrogen atom, there is a transition, and this is N1, this is say N2, a photon is emitted, and the lambda is given as 6569 angstrom. 6569 angstrom. Which transition you believe this will be? First option is 4 to 2. Second is 3 to 2. Third is 2 to 1. And fourth is 3 to 1. Come on. Which transition you believe? Which you will discard? Which options you will discard first? Because this is not possible. This is not possible, and this is all about hydrogen atom. Third and fourth are not possible because third and fourth belong to Lyman series, and Lyman series belong to what? Ultraviolet region. Yes or no? And this range particularly is between 4,000 to 7,000 angstrom. 4,000 to 7,000. That means we will be in the visible region. Visible region means we will be in the Balmer region. Balmer region means 3 to 2 or 4 to 2. But if you are a little bit careful, you will see that between this 4,000 to 7,000, 6,569 is very close to 7,000. I mean, out here there will be something like 5800. Then this will be like say maybe 5,000, and the fourth line, I told you there are 4 visible lines, so 4 will be maybe like say 4,200 kind of thing, maybe. Yes or no? So I believe this will be the first line. This is the first line, like which is the red line. Akina? Yes or no? So my guess will be like say going for the second option. 3 to 2. This is very near to 7,000, very near. And these are all rough values. They're all rough values, bache. Are you getting it? 4 to 2 will be second line. Second line will be like say, something around 5,500 kind of thing. Yes or no? Are you getting it? So these are intelligent ways to handle these things with a common sense. Otherwise, you will have to find the exact answer for that. When I'll teach you energy of hydrogen atom, we will do this question in a single line again. We'll do that question in a single line, okay? With the help of energy. That also I'll teach you. Is that clear? Is that clear? Okay, come. Now come and write down Bohr's model. Bohr's model. Come on, write down Bohr's model. So first of all, write down 3 statements which are very important. The first one is that his model is based on classical physics and quantum physics His model is based on classical physics and quantum physics or quantum mechanics. One and same thing. Quantum physics or quantum mechanics is one and same thing. Was getting that? Okay. But remember that this is also his greatest defect. This is also his greatest defect. Why this is the greatest defect? The reason is that according to classical physics, light is continuous, energy flows continuously. But according to quantum physics, light is particle-like, discontinuous in the form of photons, and energy is again discontinuous or discrete in the form of quanta. This is photon, this is quanta. Yes or no? He was trying to combine continuous and discontinuous. Now continuous is definitely not discontinuous. So his was an act of desperation. He wanted to somehow find something to explain hydrogen spectrum. So he borrowed from classical physics and he borrowed from quantum physics. And this was his nemesis also, his greatest defect. Agree or not? You can't equate continuous and discontinuous. Light can be either continuous or it can be discontinuous. Yes or no? Second, please write down second point. Second point, according to Bohr, electron is a particle. According to Bohr, electron was a particle. So he believed in the particle nature of electron. He believed in particle nature of electron. Okay. Then third one, and very important, His model is applicable. His model is applicable. His model is applicable only for one electron species. Only for one electron species. Only for one electron species. Now, when I say one electron species, the examples are hydrogen, helium plus, lithium 2 plus, beryllium 3 plus. I mean, take out all electron except one, and so on, like maybe sodium 10 plus also, and many more. It is applicable only for one electron species. Okay? Done? Okay. Now, we will be doing the postulates. Postulates given by Niels Bohr. So when someone gives postulate, bachcho, it actually means that he is not aware about the mathematical proof of that. He does not know how he will be able to prove it. So he's not having a solid background. He's assuming that. He's saying that if we assume what I'm saying is right, you will find all the answers of hydrogen spectrum. All the answers. And if you are getting all the answers correctly for hydrogen spectrum, which means that there is something right in my theory. This was what actually Bohr was trying to tell the scientist community, that you listen to me, whatever I am saying, these are my assumptions, but with these assumptions, you will get all the answers for all the questions of hydrogen spectrum. And if I am correct, that means there is some element of truth in my theory. So listen to that. So maybe I do not have proof of that or the derivations, but someone in the future will get those proof, all those derivations. And yes, someone else is none other than de Broglie or de Broglie. The de Broglie is the incorrect pronunciation. The correct pronunciation is de Broglie. De Broglie will give all the explanation for this theory, beta. So can we begin that? I won't give you any written statement. Just listen to me. All of them are listed in NCERT and in a module also. You can read it from there. So he said the first assumption was, first postulate, that hydrogen contains a nucleus which contains a positive charge, and there is an electron, and this electron will revolve around the nucleus. And this thing he borrowed from where? This thing he borrowed from where? Rutherford. Very good. He borrowed this from Rutherford. Yes or no? Secondly, he said that no, it's not as if only one orbit is there. There are infinite such orbits. There are infinite such orbits. Okay? In which an electron can live, which we have discussed earlier also. And what I'm saying is that, again he said something. He again said that not only all orbits are possible, only those orbits are possible for which the orbits have one condition satisfied, that all these orbits should have one condition satisfied. What is that? The MVR, angular momentum, should be integral multiple of h upon 2 pi. Integral multiple of h upon 2 pi. Yes or no? Where n is what? 1, 2, 3 and so on. All the natural numbers. Are you getting that? Yes or no? This is called quantization of angular momentum. You have seen two more before this thing. So Q equal to N into E. Quantization of charge given by Millikan, and energy equal to N into H nu. This is called quantization of energy given by Max Planck. And again E equal to what, beta? Over here, so not E. MVR is equal to N into H upon 2 pi. So we are right now into quantization of angular momentum. These are, like, say, some important things. Slowly and slowly we are moving into quantum world. Okay, earlier we saw that charge is quantized, then we saw energy is quantized, and now we are seeing what? That angular momentum is also quantized. Yes or no? This was given by Millikan, Planck, and now Niels Bohr. Is that clear? Okay, now let me ask you one question. Let me ask you one question on that. The question says that which is possible? Which is possible? Be careful. Be careful. First option, MVR is equal to 5h upon 2 pi. Okay, then second, MVR is equal to 3.5h upon pi. Okay, then we are having third option, MVR is equal to h upon pi, and fourth option MVR is equal to 3h upon 3 pi. बोलो बच्चों, which option? नहीं, mole concept we will do after this, है ना? After this, okay? Come on, which options are possible? Come on, everyone. Vasant, good morning. Come on. Which options are possible? Okay, great, great. Come on. Be quick, be quick, be quick. So what I taught you right now, I taught you only those values of angular momentum are possible for which we have got integral multiple of h upon 2 pi. H upon 2 pi is compulsory. Don't answer these kind of questions before you make h upon 2 pi. So see that this is integral multiple of h upon 2 pi, correct answer. But this is what? H upon pi. Don't answer if it is h upon pi or anything else. Don't answer before you make it h upon 2 pi. I believe this will be 7 into h upon 2 pi. This is 7 into h upon 2 pi. Now this is the integral multiple of h upon 2 pi. Bache, don't answer in the format of h upon pi. No, first make it h upon 2 pi and then see this number is an integer or not. If it is integer, then it's okay. Otherwise, it's wrong. Okay. Now this is same thing, h upon pi. Don't answer it right now. Make it 2h upon 2 pi. One and same thing, beta. This is same thing, but now it is integral multiple of h upon 2 pi. This is also possible. This is also possible. How about this one? 3 and 3 will cancel. Don't answer in the format of h upon 3 pi. Answer it always in the format of h upon 2 pi. So this will be what, beta? H upon pi. Now h upon pi is same thing. This is same thing now. You can multiply by 2 and divide by 2. H upon 2 pi. All the options are correct. All of them are correct. Yes or no? The idea is that angular momentum is the integral multiple of h upon 2 pi, not of h upon pi, h upon 3 pi or whatever. Are you getting it? This is a common mistake people do. And I told you, you people don't play googly very well. Yes or no? Okay. Okay, now see that stuff. Look up. This is important. And he also said that if an electron is revolving in an orbit, if electron is revolving in an orbit, it will keep on revolving in the same orbit without gaining energy and without losing energy. Without gaining energy, without losing energy. And he said that if an electron gains energy, it will move from lower to higher orbit. But if it loses energy, it will come from higher to lower orbit. And in that case, it will also emit a photon and whose energy will be delta E equal to what? En2 minus En1, where N2 is more than N1. Yes or no? Where N2 is more than N1. And this delta E for this photon, this delta E will be equal to what? H nu and Hc upon lambda. Yes or no? Okay, who will tell me that this lambda belongs to the photon or the electron which is jumping? This belongs to photon or the electron? This lambda. Everyone should answer it. Everyone. This lambda is of this photon, but see that this photon is moving with the energy of delta E. So this delta E is the energy of the photon emitted, whose wavelength is lambda. Moreover, photon travels with the speed of light. Photon travels with the speed of light, not electron. Are you getting it? So this frequency and this wavelength, they belong to whom? Photon. Are you getting it not? And moreover, remember that as of now, according to Niels Bohr, Electron is a particle. Electron is a particle which does not have any wavelength as of now. According to Niels Bohr, electron is a particle, not a wave. Yes or no? Someone will come and will prove him wrong later on, but that's a different theory. According to Bohr, electron is a particle. Yes or no? So only photon can move in the format of waves. Okay? Yes or no? Chalo, theek hai. Okay, now we come to this part. Hai na? Now we'll discuss the radius, energy, velocity, frequency of the electron. In what? One electron species. Bohr's model is only valid for one electron species. Yes or no? Yes or no? Okay? Chalo, aa jao. Dinesh is saying that electron is both. Yes, it is both, but it will come later on. As of now, till Niels Bohr's theory, electron is assumed to be a particle. De Broglie will prove that electron is a wave also, can behave like a wave also. Okay? Chalo, aa jao. So let's do the radius now. Let's do the radius of all the one electron species. So actually the formula for this is R, and N is the orbit number, equal to what? It will be N square H square upon 4 pi square M K Z E square. Remember that. Now there are certain books you might be doing in which they ask you that what will happen to radius if the mass, this M is mass of electron, this E is charge of electron. Remember that. So what will happen to radius if the mass of electron doubles? What will happen to the radius if the mass of electron is doubled? Come on. It is inversely proportional. Can you see that? This radius is inversely proportional to mass of electron. It will become half. It will become half. Very good. Now similarly, what will happen to radius if the charge of electron doubles? If the charge of electron doubles, come on. It is inversely proportional to E square. It is inversely proportional to E square. Become 1 by 4. Very good. Very good. But like in all the booklets, I mean the formula given is what? 0.529 into N square by Z. But angstrom. Now this formula does not tell you anything about the mass of electron and charge of electron. Agree or not? Come on. This simply tells you about N and Z, but not on mass, not of electron. So one question might be missed. So that's why I have given you this stuff. So be careful, bachcho. Okay? Our job is to give you a world-class education, bachcho. You just need to revise it, practice it. Is that clear to all of you? Okay. Now, once you are there, chalo, tell me one thing. So N means orbit number, first orbit. Na? So R1 will be how much? 0.529 into 1 square upon Z for any one electron species, beta. R2 will be 0.529 into 2 square by Z. Similarly, R3 will be 0.529 into 3 square by Z. Acha bachcho, tell me one thing. Tell me one thing. What is this? What is this thing? This is R1 because this is 1 square is only 1. 1 square is only 1. What is this thing? R1. This is also R1. So R2 is what? R1 into 2 square. What is this? R1. R3 is R1 into 3 square. Come on, tell me. Similarly, R1, if they give you R1, the value of Rn will be R1 into N square. N square. Very good. Very good. Very, very good. Brilliant. Hai? So if we give you the radius of orbit number 1, you can calculate easily any radius now. So tell me, who will tell me that if R1 is given as X, radius of first orbit is X, what will be R10? What will be R10? Come on. Find the value of R10. Come on, everyone. It will be 100x. N is 10. 10 square, 100. So R10 will be 100x. That means radius of the 10th orbit will be 100 times more than the first radius. Agree or not? Good, very good, very good, very good. Acha, now see that stuff. Now we also know that R is proportional to n square by Z. Okay. All these things we are doing are valid for one electron species, which contains only one electron. Now come on. Question I'm giving you: for any one electron species, for any given one electron species, it can be hydrogen, it can be or helium plus or lithium 2 plus, anything. Find R1 is to, R2 is to, R3 is to, R4. Come on, find the radiation ratio. Dekho, if you're taking one atom or one species, R is proportional to n square by Z, but since Z will be same for hydrogen or say helium, so R is proportional to n square. R is proportional to n square, so R will be proportional to n square, which means what? 1 square is 2, 2 square is 2, 3 square is 2, bolo bachche yaar, 4 square. And this will be what? 1 is 2, 4 is 2, 9 is to 16. Very good. 1 is to 4 is to 9 is to 16. Excellent. Excellent, bache. Excellent. Very good. Yes or no? Acha, remember that. But these are the values of the ratio. These are not the absolute value. So absolute value of the radius will be maybe x. This will be 4x. This will be 9x and 16x. So when you will take the ratio, x will cancel out and you will get simplest possible numbers. Is that clear? Is that clear? Now, but if I ask you, look over here and please focus. Say for example, this is the nucleus. Say this is the first orbit, and this is, boys and girls, the second orbit. Then okay, we'll improve upon that. We'll improve. Say we are having a second orbit, we are having a third orbit, we are having a fourth orbit. So bache, what is the distance of the first orbit? Is say x. This is say x. Second orbit 4x, 9x, and this is say 16x. A very famous question they ask beta is that the difference between R2 and R1 is how much? 3x, 4x minus x. Distance between the third and second is how much? 5x, and here the difference is how much? 7x. Agree or not? 16 minus 9x will be equal to 7x. 9x minus 4x will be 5x. So can you see that the distance between two consecutive radius is increasing as we are moving away from the nucleus? Yes or no? As we are moving away from the nucleus, the distance between two consecutive radii is increasing. So can I conclude that R2 minus R1 will be less than R3 minus R2 will be less than R4 minus R3? Will you all agree or not? Come on, and so on, and so on. So as you keep on moving, the difference between the two consecutive radii also increases. With the energy, you will see that the reverse order will be there. With energy, reverse order will be there. So it becomes very important that you focus on the minute details. Getting it done? Okay? Shall we? Okay. Now go. Question. Find R1 of hydrogen is to R2 of helium plus is to R3 of lithium 2 plus. Radius first, the radius first of hydrogen, radius second of helium plus, and radius third of lithium 2 plus. Find the ratio. I believe that here Rn is proportional to n square by z. So R is proportional to n square by z. So here n is what? 1. 1 square by z is also 1. Come on. R2, 2 square upon z is also 2. 3 square, z is also 3. Come on. You're taking too much of time. Answer it. Now 2 and 2 will cancel, 3 and 3 will cancel. Answer will be 1 is to 2 is to 3. Yes, good. Very good. Very, very good. Excellent. 1 is to 2 is to 3. Very good. बहुत अच्छा कर रहे हो. Doing very good. Keep it up. Okay. Acha, can I ask you a general question, a common sensical question? And just answer it quickly. Common sense question. Which radius will be bigger? The first radius of hydrogen or first radius of helium plus? Which radius will be bigger? First radius of hydrogen or first radius of helium plus? Which will be bigger? Common sensical. Be quick. Fastest fingers first. Who will have the larger radius? Hydrogen or helium? Dekho, one thing is for sure, this is a really good batch. Really good batch. Boys and girls, please keep on doing serious studies with lots of practice. You will do excellently good. Your answers are way better than the student I'm teaching right now here. Most of them, they have given the wrong answer. And you are giving, almost all of you are giving the correct answer. Getting it? So good one. Keep it up. Keep it up. See that, bacho. I'll tell you common sense. First I'll solve it common sense, then I'll solve the formula also. Like in hydrogen, bache, we have got only one proton. But in helium plus, we have got two protons. Now two protons will pull the electron more closer. Yes or no? In helium plus, electrons will be pulled more closer because of the two protons. One proton will not pull the electron that much. So electron will stay away in hydrogen, but in helium plus, they will be coming more closer. So the radius will decrease. Yes or no? In hydrogen, only one proton is there, electrons are far away. But in this helium plus, we have got two protons. They will pull the electron more closer. Yes or no? And now we can go with the formula also. We can go with the formula also. Like, see that? So I'm saying R1 of hydrogen is to R1 of helium plus and is to R1 of lithium 2 plus. Now we know that R is proportional to N square by Z. Now N is same, 1, 1, 1 each. So R is proportional to 1 by Z. Yes or no? So R is proportional to 1 by Z, which means what? 1 by 1 is to 1 by 2 is to 1 by 3. Or you can simply say that, take the LCM, 6 is to 3 is to 2. But here I can see that radius of the first orbit of hydrogen, if it is 1, radius of the helium plus will be half. That means radius of hydrogen is double than that of helium plus. Yes or no? Agree or not? And radius of first orbit of hydrogen will be 3 times more than that of lithium 2 plus. Are you getting that? Not helium. It has to be helium plus, bache. See that? I've written that. Helium plus. This is helium plus. Mohammad Siddiqui. Clear hai? Helium plus in hydrogen. Mohammad, come on, reply. Is that okay? Good, very good, very good. So over here we are. Acha, now see that. Understand few things also, na? First few things also, beta. That see, this is the nucleus according to Niels Bohr, and this is the first orbit. We're having a second orbit, third orbit, fourth orbit, and so on. And then we have got infinite, orbit number infinity. Abhi, kya chala gaya? Hai na? Orbit number infinity. See that? Orbit number 1, 2, 3, 4, 5, and so on till orbit number infinity. Their nomenclature is beta K, L, M, N, O, and so on. And so on. Yes or no? This orbit number 1 is also called ground state. Ground state. Orbit number 2 is called first excited state. Orbit number 3 is called second excited state. And orbit number 4 will be called third excited state. Yes or no? Remember that. They will ask some beautiful questions on that. Are you getting it? Good. Very good. Now, remember one more thing. the energy required to move the electron from orbit number 1 to orbit number infinity is called ionization energy. The energy required to move an electron from orbit number 1 to orbit number infinity is called ionization energy. One more thing you have to understand, that orbit number infinity is also called free state of electron, and remaining all inside orbits are called bounded states. So when I say bounded state, it means that electron is bounded by the electrostatic attraction of the nucleus. But when they are in the orbit number infinity, it is free electron. It is no more under the influence of the nucleus. It can go anywhere. Yes or no, Kusuma? Okay, good. Very good. Very good. Acha, one more thing, beta. One more thing. Energy required to move from electron from orbit number 1 to 2, or orbit number 1 to 3, or orbit number 1 to anyone, but not orbit number infinity. This is called excitation of electron. This is called excitation of electron, and the energy required is called excitation. Excitation energy is called excitation energy. So here we have got a very important thing coming up. A very important thing coming up. That first excitation energy will involve which orbits? N1 to N2. Come on, 1 to 2. First excitation energy. Motivate you. Okay, I'll motivate that, but I mean today we have to cover up certain things. I'll do it. I'll do it in a coming lecture, but so don't worry at all. I'll definitely do it. First excitation energy is that energy required to move electron from orbit number 1 to orbit number 2. Come on. Second excitation energy will involve which orbits? Second excitation energy will involve which orbits? Come on. There are questions in the module on this. I mean, I told you, you are very poor at playing googly. Something which is already excited, you can't excite it. You can't excite something which is already excited. Excitation is only from orbit number 1. You can excite something only from orbit number 1, ground state. If something is already in the higher excited state, it is already unstable. It won't go up. It will have a huge tendency to come down. Yes or no? It will come down. Yes or no, boys? 1, 2, 3. Chalo, batao. Third excitation energy will involve orbit number 1 to 4. Yes or no? And similarly, 10th excitation energy will involve 1 to orbit number infinity. 1 to orbit number infinity. Oh, sorry, 11th. 1 to 11th. Sorry, my mistake. 1 to 11th. Okay. Okay. Now understand one thing. If you take out electron, that is done. That is done. That is done. Okay. Come on, tell me one thing. Question. Find ratio of, write down the question please. Ratio of radius. Find ratio of radius of third excited state. Third excited state of beryllium 3+. Third excited state of beryllium 3+ and 10th excited state of sodium 10+. Of sodium 10+. You have to find out the ratio of the orbits of third excited state of beryllium 3+ and 10th excited state of sodium 10+. Come on. But before that, what do you think the value of n will be? The value of n will be 4 over here, and value of n will be 11. 10th excited state means orbit number 11, and this means orbit number 4. Now we know that R is proportional to n square by z. N square by z, because n is also different, z is also different, n different, z different. Understand that? So now I can very well say that R4 of beryllium 3+ upon R11 of sodium 10+ will be what? N square for beryllium, 4 square by Z of beryllium, 4 upon N square of sodium is what? 11. 11 square upon Z of sodium. What is that? 11. Who said the answer? Who said the answer? Dinesh. Dinesh correct. Dinesh correct. So 4 and 4 cancel. 11 and 11 cancel. This will be 4:11. 4:11. Vijay correct. Joshna correct. Very good. Dwarkadhish correct. Oh, Bhagwan Krishna hai to. Dwarkadhish ji, very correct answer. Manish correct. Now everyone is getting correct answer. Very correct. Very correct. Just one last question we'll do. A very important question. A very, very important question. Last question. See that? They're saying that the ratio, please write down, the ratio of radius of any two orbits, the ratio of radius of any two orbits in hydrogen is 1:9. Is 1:9. Find nomenclature of the orbits. So when I say nomenclature, beta, I mean K, L, M, N, O, P, Q. Okay, it's a very important question. Very important question. Find the nomenclature of the orbit. See that. Now the atom is same, hydrogen. That means R is proportional to N square by Z. Z will be same. So R is proportional to N square only. Now see that. Rn2 upon, or Rn1 upon Rn2 will be what? N1 square upon N2 square equal to what? 1/9. 1/9. This will be what? Come on. Take the square root. N1 upon N2 will be equal to 1/3. Now this is the ratio. Boys and girls, please listen to me. That's what I'm saying. Your answers are correct. But what NEET is looking for? NEET is looking for something different. I have got no doubts with what your answers say. Now, when I get a ratio is the simplest version of all the possible numbers, simplest ratio. But there are billion ways to get the same ratio. 1:3 is also 2:6. This is also 3:9, and so on. There are billion ways to get the same ratio. Will you agree or not? So here we are right now, and so on. And I know one thing, that orbit number 1, 2, 3, 4, 5, 6, and so on. And this is K, L, M, N, O, P, and so on. Are you getting it? Now, 1 and 3 is one combination. 1 and 3, which means what? K and M. So first option can be K and M. Second option can be 2 and 6. Second combination is 2:6. So this can be 2 and 6 is what? P. So L and P will be the answer. Now in NEET, what kind of questions you will get? In NEET, you will definitely get which options? First option will be KM, second will be something else, but third option will be LP, and fourth will be both first and third. Both first and third. Are you getting that? So your answer was correct. But what NEET is looking for is option number 4. So please go with that. They are trying to check your knowledge, whether you know or not, that there are billion ways to get the same ratio. Yes or no? Everyone? So boys and girls, revise it. In the next turn, we will do energy. Energy is the most important part of Bohr's atomic structure. Okay? So come prepared with that. We'll do energy in the next lecture, and we'll try to cover up frequency also. Okay? Bye-bye, all of you. Have a good day ahead. Bye-bye. God bless you all. Bye-bye.